helping you. We're learning this. Anyone?
Would be 5x to the 4 minus 2e6x times 6.
That's it, times the inner function prime. Yes, I'm going to multiply these two, and I cannot do anything else. This is it. Thank you. Who was that?
Sam.
Sam, thank you. Very good. Awesome. Any questions? Okay, so let's choose something else. Let's say 35. X times e to the x. Or maybe even 36. Let's do 36. It looks a little bit better. Yep. So let me copy it. 36 on the same page, 210. So we have y of x equals x squared times e to the x. Perfect. Okay. Can anyone dissect this in a way and say, oh, you have to use this rule? What rule I have to use here? Can anyone tell us which rule we have to? The product rule. Very good. Awesome. Awesome. So I make myself a note if I need to. First function, second function. Awesome. So let's do that. So page 5. So y prime or dy over dx. Remember that we have two different notations. So we differentiate the first function. So remember the rule. You can write it on the side if you're having any doubts. Yes, you can twist it the way you like. I like it 1, 2, 1, 2, 1, 2, but whatever works for you is fine with me. So can anyone give us the first function prime?
2x.
Excellent. Times e to the x. So this is done, and this is done. Good. Now I have plus. I copy the first one. Can anyone give us the derivative of e to the x? It's a very friendly function. We love it. E to the x. You can leave it alone. You can factor out if you'd like. Later on, we will have to x e to the x. And then we have 2 plus x, or x plus 2. So this is fine either way. Should we look at anything else? If not, I like to look at word problems. So choose. Yes, it was asking us for the second derivative. I always forget that. Okay, so let's do the second derivative. I forgot that before. Okay, so do not look at this. We prefer this setup because I don't want to complicate it with parentheses. But now I have to apply the product rule twice. This is the first function. This is the second function. This is another function, function 3. This is another function, function 4. So I have to apply the product rule twice. So let's differentiate 2x. What do we get?
2.
That's it. And I have to multiply by the second function, plus. I keep the first function, and I have to multiply by the second one prime. But this is a nice function. This is the nicest of all. E to the x prime is e to the x. So now we have to apply the product rule on this. Plus, we differentiate x squared. What do we get?
2x.
Very good. Awesome. And I have to copy the second one. Awesome. Plus, I keep the first one. And again, this is the nicest function as long as it's x. Because if it's 3x, I also have to differentiate the 3x.
Yes.
Perfect. So I see that these two can be combined like terms. I'm going to start with this one. So x squared e to the x. And can anyone combine these two and tell us what to write? They are the same term.
Is it 4 4.
Excellent.
X.
Yes, awesome. And plus 2 e to the x. Yes, if you want to be fancy, you will factor out e to the x, and you will get x squared plus 4x and plus 2. Good. Can we move on to applications? Is that okay?
Yes.
We can come back to other problems anytime. I like to apply, I'm trying to make it as interesting as possible so you see when this is used and why, and etc., etc. Should we look at depreciation this time?
Yes.
Okay, so let's look at depreciation, 51 on 211. I'm not sure if the pronunciation is correct. It could be French, it could be Perriot. I'm not sure. Maybe Sandley, you can help us. Is it Perriot? Is it correct?
Yes, Perio.
Perio.
Like the tea salads. Yeah.
Yes, Perio. Very good. Perio's restaurant purchased kitchen equipment on January 1st, 2017. On January 1st, 2019, 2 years later, the value of the equipment was $14,450, and they are giving us V of t. V of t equals 14,450 and e to negative 0.163 t. What is the rate of change in the value of the equipment on January 1st, 2019? Meaning 2 years from the moment it was established. 2017 is the original, and 2019 is 2 years later. So
do you plug 2 and t?
Careful. We need to talk about the rate of change first before we even think of plugging in anything. So what is the rate of change? What does it mean? Remember that those 4 concepts, the rate of change, the average rate of change, the instantaneous rate of change, yada, yada. So what does this mean?
The equipment got old.
Careful. What is the concept of the rate of change? When we're asked to find the rate of change of a function, what are we trying to find?
Find the function's prime.
Yes. Thank you. Who was that?
Sam.
Sam, thank you. So the rate of change, before we even evaluate it, has to be determined first. And then I'll see whatever I need to plug in. But I am asked to find the rate of change first. So first I need this function, and then I plug in whatever I need to plug in. So let's look at this function. It has a constant in front, e to a function. So let's establish v of t, or find v of t, v prime of t, of course. So I copy the number, and then how do I differentiate this? Remember the formula? This is e, this is e to a function prime. And I'm going to delete it from there because I don't want you to get confused. So can anyone help us differentiate this piece that is boxed in here? How do I differentiate this?
Would be e to negative 0.163 times negative 0.163.
Times negative 0.163. Awesome. And of course, I have to multiply this by this and put the number in front. So I'm going to plug it in the calculator. I don't know what that is. 14450. I know the number is going to be negative 16.163. Oops. So yes, that's correct. Yes. So enter. So 23, so minus in front, 2355.35 times e to negative 0.163 t. Awesome. So this is the rate of change. Now, what I did not write, and that is not something that we should do ever. So the value of the equipment, so I have to write in somewhere, it's in dollars, and T is the number of years. The value after that date model equipment, so I'm assuming it doesn't say for sure, but it's in years. So T in years. Good. So now, can anyone tell us what would be the measurement unit? We haven't evaluated this function for anything yet, but what would be the measurement unit for v prime of t? That's why I established this, and I established this just for us to make sure that we don't forget to write the measurement unit.
Dollars per year.
Very good. Dollars per year. It's a rate of change. It's a rate of change. It has to have, thank you very much, it has to have two measurement units. One coming from the function at the top, and the other one coming from the independent variable in the denominator. Perfect. Okay, finally, what do they want? So we established all these things. Where is my function? Here it is. So what is the rate of change in the value of the equipment on January 1st? So now they purchased the kitchen equipment on January the 1st, 2017. On January the 1st, 2019, the value of the equipment is the $14,450 that you see here. The value after that date is modeled by, so time equals 0 represents 14,450, that's the value. But they want us to find the rate of change on that day. What do I plug in V?
The 2 years.
That was in 2017. They want us to determine in 2019 the rate of change exactly January 1st of 2019. So in part A, V prime of 0, because the function has the value of 2019. So V prime of 0, when this is 0, this whole thing is 1, as we discussed a few minutes ago. So this is negative $2355.35 per year. Good. Let's see what they want part B. What was the original value of the equipment on January 1st of 2017? So what do we do then? So we know the value in 2019 was this. So now we want to determine the value, the original value of the equipment on January 1st of 2017. So let's see how we do that. So this has nothing to do with the rate of change. They want the value. They want us to determine V of something, not the rate of change. We determine the rate of change in 2019. So this is in 2019. But they want us now to determine the value that was initially. So obviously the value has to be bigger than this, because this is depreciation. So in 2017, the value has to be more than 14,450. It decreased and to 14,450 from 2017 to 2019. In 2019, per year, it decreased with this amount. So how, yes?
Would it be V of negative 2?
Yes. So let's plug it in. Thank you very much. So where is my calculator? Okay, so 14450. That's why I'd like to have the function in there so I can check, plug it in and not have to enter it all the time. But it's one value, that's okay. So because I know it's negative times negative, so it's going to be 2 times 0.163. So I don't have to crash 2 negatives in there. And this is 20,019.25. As expected, $20,019.25 in 2017. And this is not the rate of change. This is the actual value when it was purchased. They purchased it at $20,019.25. It decreased 2 years later to $14,450. And the rate of change at that time was negative, decreasing, negative $2,355.35 per that year. Okay, so I would like us to continue with, where's my book here? So page 216, and enter. Let's practice a little bit. Let's choose from practicing how to differentiate log. If you'd like, yes, if you'd like to choose, or I will.
Number 2.
Number 2. Very good. And which page am I on? I'm on 6. Because if I don't number them correctly, then who knows how I. So this is 2016, 216. So who knows which order I scan them in. So I have to be careful. Good. So perfect. So we want to find y prime or dy over dx. Can anyone help with this? So the constant stays outside. Can anyone differentiate natural log x for us with the formula?
1 over x.
That's it. Or negative 8 over x. Perfect. Awesome. That's all there is. My turn to choose. I'm going to choose 13. So we have y equals natural log of 3x squared plus 2x minus 1. I know it looks very difficult. Not at all. Ready. So can anyone try y prime? It just looks difficult. It's not. Natural log of a function prime. So let's look at the formula. See, I never have them in the correct order here. Natural log of a function prime is 1 over the function times the function prime. Anyone?
1 over 3x squared plus 2x minus 1 times 6x plus 2.
That's it. Yes, we can. Very nice. Thank you very much. So we can condense it nicely. But this is good enough. No problem there. Okay. So let's look at a word problem. We're going to practice more, but I just want to give you all the ins and outs and also look at a word problem today.